In the previous lesson, we learned how to count atoms in a compound using the unit mole instead of using the unit atoms. Now, why do we use the unit mole? Well, that's because the unit mole is the unit that connects to any other unit that we can use in our daily life. For example, we have mole and grams, we have moles and liters, or we even have mole to mole, or even mole to ions, and that's why we count everything in the unit mole. Because with mole, we can exchange or convert to any other unit. For example, in this case, we have calcium hydroxide. In 1 moles of calcium hydroxide, we have 1 moles of calcium, or 2 moles of oxygen atom, or 2 moles of hydrogen. So in this case, we are going to take that same concept in terms of mole, and we're going to balance a chemical reaction. For any chemical reaction, you already know that the reactant combine together to make the product. And all chemical reactions follow this law, the law of conservation of matter. Basically, the amount that you put in on the reactant side must equal to the amount that you put on the product side. Now let's explain that in terms of mole. Basically, the number of moles of each element on the reactant side must equal to the amount of moles of that same element on the product side. And if the moles is the same for each of those elements on both sides, so does the mass, so does the number of those atoms. So that is basically the law of conservation of matter. In order to prove that law really exists, we have to balance a chemical reaction or chemical equation. In this video, we are going to focus on how to balance a chemical equation. There is only one rule that we need to follow, and that is you can only change the coefficient, and that's the number in front of a chemical formula. Because if you change the coefficient, it will change the values of all the elements in that particular compound. And the trick is to change the coefficient so that both sides, the product and the reactant, equal each other. So let's do one problem as we try to explain the process of balancing chemical equation. The first thing we need to do is to make a list of all the elements on both sides, the product and the reactant, so that we know it is balanced, okay? So let's draw a line right between the reactant and the product side. And on the reactant side, we have calcium, and we have hydrogen, and we have oxygen. And how many calcium do we have? Just 1. Ignore the S and the G, those are the state of matter of the substance. And the hydrogen we have 2. And then for the oxygen we have 1. And on the product side, the list of elements would be the same as the reactant side based on the law of conservation of matter. So CaHO. And how many Ca do we have in this case? Just 1. And how many H do we have? Well, in this case, we have 2 right there, and we have 2 more. So that gives us 2 plus 2 give us a total of 4. And what about for oxygen? We just have 2 times 1 right here. That gave us 2. Now, let's go back to the rules. First, we have to balance the metal first. Balance any metal that you see first before balancing any non-metals, okay? And then if we have a polyatomic ions, these are all the common polyatomic ions. We need to balance them as a unit. And I'm going to show you how easy it is if you balance a polyatomic ions as a unit, okay, instead of looking at the individual element in the ions. Lastly, balance any hydrogen or oxygen last. Well, I'm referring to the elemental hydrogen and the elemental oxygen, okay? They exist by themselves in the chemical reaction. So let's go back and follow the rules. For example, we have calcium is our metal. So in this case, the calcium is already balanced already, so we don't have to do anything to it. Now, let's look at this right here. Polyatomic ion. Isn't this a polyatomic ions? Well, instead of looking at this polyatomic as in terms of oxygen and hydrogen separately, why can't we just revise this list, okay? Let's put in an addition list right here where I have OH. How many OH do I have? 2. Well, over here, there must be an OH somewhere, and that is coming from here. This water is actually HOH, and this is the polyatomic ions right here. So we're going to make an additional list on this, okay? This is our main list, but this is something that we're going to try to use a polyatomic ions to balance. In this case, how many of OH do we have? We just have one, okay? So keep that in mind. We balanced the calcium. Now let's look at the polyatomic ions. How many OH do we have here? We have 2. So therefore, this side must have 2 as well. So over here we only have 1. What coefficient go here can give us 2 OH? Of course, the coefficient is going to be 2 because 2 times give us now 2 of the OH minus. So now using that, how is that going to affect our list of elements? In this case, if we put a 2 there, now we're not going to have 2 hydrogen anymore, but we're going to have 2 times what? 2, that give us a total of 4 hydrogen. What about the oxygen? Of course, we're now going to have 2 oxygen as well, and that's it. Now do you see the benefit of balancing polyatomic ions as a unit instead of each individual element? And of course, the one that doesn't have a coefficient change will all be 1. So our answer is 1, 2, 1, 1. And this proved the law of conservation of matter because the number of the reactant side for each element is equal to the number of the elements on the product side. So both sides will have equal number of moles as well as equal to number of grams or equal to the number of atoms.